Are you ready to uncover the truth behind one of Earth's most mysterious events? 65 million years ago, the Earth was a very different place. Giant dinosaurs roamed the land, dominating the planet for over 160 million years. But one day, everything changed. An asteroid struck the planet, wiping out the dinosaurs and changing the course of history. What was it made of? How big was it? And what effects of its impact? In this video, we'll take you on a journey through time and space as we unravel the secrets of the asteroid that caused the Cretaceous-Paleogene extinction event. From the latest scientific findings to stunning visualizations, you won't want to miss this.
Audio Jungle.
There have been several recent studies and hypotheses about the extinction of dinosaurs. Still, one of the most widely accepted theories is that an asteroid impact was the primary cause. This theory suggests that an asteroid or comet struck the Earth, causing a massive explosion and creating a nuclear winter effect that killed off the dinosaurs. This massive asteroid was roughly 10 kilometers in diameter, hurtling towards the Earth at over 20,000 miles per hour. When the asteroid hit the Earth, it created a massive explosion, equivalent to the energy of 10 billion atomic bombs. This explosion created a huge crater known as the Chicxulub crater, approximately 150 kilometers, 93 miles in diameter, and 20 kilometers, 12 miles deep. The impact also sent huge amounts of dust, ash, and debris into the atmosphere, creating a nuclear winter effect that blocked out the sun and cooled the Earth's surface. This caused a dramatic climate change, leading to the extinction of many species, including the dinosaurs. The dust and debris also caused massive wildfires which spread across the world, and the heat generated from the impact created tsunamis that reached across much of the Caribbean, killing anything nearby. The asteroid impact also created a considerable amount of sulfuric acid due to the vaporization of sulfur and other volatile elements, which would have mixed with water vapor and produced acid rain. This would have further damaged the ecosystem, poisoning and killing off many plants and animals. In addition, the impact also caused massive seismic activity and volcanic eruptions, which would have created even more deadly conditions for dinosaurs and other species. Overall, the asteroid impact was a catastrophic event that created a chain reaction of destruction, ultimately leading to the extinction of the dinosaurs and many other species. And essential evidence supporting this theory is the presence of high levels of iridium, rare on Earth but common in asteroids, found at the same layer of clay where it is believed that the asteroid impact happened. So, yes, an asteroid did hit the Earth. While the asteroid impact theory is the most widely accepted explanation for the dinosaurs' extinction, it is not the only one. Other hypotheses include volcanic activity, climate change, or disease, but none of them has the same level of evidence as the asteroid impact. It's important to remember that while the asteroid impact played a crucial role in the extinction of the dinosaurs, it may not have been the only factor. The asteroid impact may have created the initial conditions that caused the extinction, and other factors such as climate change or disease may have played a role in finishing off the dinosaurs. But where did the asteroid come from? The asteroid that caused the mass extinction of the dinosaurs around 66 million years ago is thought to have originated in the asteroid belt between Mars and Jupiter. Asteroids in the asteroid belt are made up mostly of rock and metal and are thought to be remnants of the early solar system that never came together to form a planet. The asteroid belt is home to many different types of asteroids, including those made mostly of metal and those made mostly of rock. Some asteroids are also known to have companion moons. It is thought that the asteroid that caused the mass extinction of the dinosaurs came from the asteroid belt and was sent on a collision course with the Earth after being disturbed by the gravitational pull of one of the gas giants like Jupiter. Some theories suggest that the asteroid may have been part of a larger body that broke apart due to the collision or other forces, releasing the asteroid that hit the Earth. In 2007, a team of scientists led by Bill Bottke of the Southwest Research Institute, SWRI, in Colorado, proposed an origin story for the dino-killing asteroid. A massive collision in the innermost portion of the central asteroid belt about 160 million years ago, which broke apart a 106-mile wide, 170-kilometer space rock called Baptistina. The hypothesis that the collision that created the Baptistina asteroid family is related to the mass extinction event that wiped out the dinosaurs is still controversial among scientists. The crash that began the Baptistina family is thought to have occurred around 160 million years ago, much earlier than the mass extinction event, about 66 million years ago. It is hard to be precise on the asteroid's origin, as it impacted 66 million years ago, wholly obliterated it, leaving no traces of the asteroid in the crater and no remnant. The asteroid impact caused massive debris and huge amounts of rock and soil, including the asteroid's material, were vaporized and mixed in with the debris ejected from the impact. Most of it went up into the atmosphere and then rained back down over the entire planet, meaning it's pretty hard to have a sample of the asteroid. In 2011, however, observations by NASA's Wide Field Infrared Survey Explorer spacecraft more or less ruled out the Baptistina hypothesis by showing that the in-space collision likely occurred just 80 million years ago or so. Researchers stated that it didn't give the newly spawned fragments enough time to move into a position from which one could be gravitationally nudged onto an Earth-crossing trajectory. In a paper published in 2021 by SWRI scientists David Nesvorny, Bottke, and Simone Marshy, the origin of the asteroid was narrowed down a bit. They used computer models to understand better the asteroid population and powerful impacts like the one that caused the dinosaurs' mass extinction. They determined that the dinosaur killer was an asteroid that formerly resided in the central belt, likely in its outer portions. Nesvorny and his team also calculated that about half of all Earth-impacting objects have more than 3 miles, 5 kilometers, wide area of dark carbonaceous asteroids. And they found that things at least 6 miles wide probably hit our planet once every 250 million to 500 million years. So, fingers crossed, another one shouldn't head our way for a long time. The dinosaurs were not the only species to go extinct. Over 75% of all species on Earth were wiped out. This mass extinction event, known as the Cretaceous-Paleogene extinction event, marks the end of the Mesozoic era and the beginning of the Cenozoic era, the era in which we currently live. But out of this catastrophe, new life emerged. Small mammals, living in the dinosaur's shadow, thrived in the new environment. These mammals evolved and diversified, developing the species we see today, including humans. The asteroid impact may have been the end of the dinosaurs, but it was also the beginning of the world we know today. So, the next time you look up at the night sky and see a shooting star, remember the asteroid that brought about the end of the dinosaurs and the beginning of our world. Thanks for watching.